In this section, we will learn about the add assembly instruction in RISC-V architecture. Add is one of the basic arithmetic instruction. It is used to add two integer values. This instruction is very common in compiled code in any of the assembly routine. So it is important to understand the syntax of add assembly instruction. As you can see, this slide shows you the syntax of add assembly instruction. As explained it, the add assembly instruction support addition operation between two the operand. So add, this is a mnemonic. The RD is the destination register. RS1, RS2, these elements are the operand. This is the first operand, and this is the second operand. RS stands for source register. RS1 is the source register 1, and RS2 is source register 2. This syntax of instruction and can be represented using this kind of representation, code, that is to add the value of the RS1 and RS2. The result will be stored in the destination register. Since the disassembly instruction has the second operand as the register, this instruction is recognized as the R-type assembly instruction. Let's explore an ADDI assembly instruction. ADDI means add immediate the value, and this assembly instruction ends with the I character. What the ADDI assembly instruction does is the same to add assembly instruction. The minor difference is that the second operand is immediate constant. Please take a look at this. There's no RS2 in case of ADDI assembly instruction. It supports addition operation between two operands. The only difference is that the second operand is the immediate constant. Now that we explore the syntax of add assembly instruction together with ADDI assembly instruction, let's analyze the C code with the corresponding assembly routine. On the left side, and what you can see is the simple basic C code. The name of the function is add function. This function takes the two parameters, the x and y, and inside this function, addition operation is performed between two parameters. As you can see, the result will be returned using this statement. If you compile this C code, and you will see this kind of assembly routine. The beginning of the assembly routine, we're going to see this assembly instruction, that is ADDI SP minus 32. So as for this assembly instruction, the first operand is SP, that is stack pointer register, and second operand is minus 32. After performing this assembly instruction, actually the subtraction operation is performed instead of addition operation, because the second operand has the minus instance value. Add ADDI assembly instruction here inside this assembly block, and another assembly code that is associated with ADDI is here. That running this assembly instruction, the value of the SP assembly instruction is updated because destination register in this assembly instruction is SP, state pointer register. Important question is why the value of the stack pointer registers is adjusted in the beginning of the function. That is a good question. Every time the new subroutine is called, the first task to do is to get the stack area to save the local variable declared in the function. So that is the biggest reason why it attempts to create a stack and frame, space for stack frame for each subroutine. Let's know that stack grow from the higher address to the lower address. So for this reason, the subtraction operation over the SP register could be performed to create the space for the stack frame. After you analyze this assembly routine, in order to understand the add I assembly instruction, you can figure out interesting pattern. That is, in the beginning of this function, you're going to see the subtract operation over SP register here. And here what you can see is the addition operation over SP register. The reason is to create the stack frame area to save the local variable at this point. And as for second assembly instruction is to retrieve the stack area right before it returns to the caller function. So moving back to the main topic of this lecture, the add assembly instruction is very common in any of the assembly routine. So let's summarize this lecture. The add assembly instruction support addition operation between two operands. An add instruction is R-type assembly instruction, and because the second operand is the register. As for ADDI assembly instruction, and as for this instruction, the second operand is immediate constant. So this instruction is considered I-type assembly instruction. Now that you got to know about the syntax of add and ADDI instruction, next lecture and we will perform debugging this assembly instruction using trace return debugging program.